we are going to use this data to discuss what we call the mean. Of course, we have done the mean before, isn't it? We know how to find the mean. After finding the mean, then we are going to use Lawman A. We're going to discuss what's called dispersion range. Lawman 2, we're going to discuss what's called interquartile range. Lawman 3, we're going to discuss what's called semi-interquartile range, or what we call quartile deviation. Then we're going to discuss what we call mean absolute deviation. We're going to discuss Lawman 4, variance. Then we're going to discuss lastly what we call standard deviation. Are you together? Now, what is the mean of this data? What is the mean of A? 56. Yes, the mean is 56. And what is the mean of P? 56. Both cases, the mean is 56. But does this max the same as this one? It's not the same. So we're going to find some measure which is going to tell us how the max is being spread. And that is what we call dispersion range. So how can we find dispersion range? So let us have dispersion range, yeah, A. So we take the highest. We're going to take the highest. What is the highest? 66. And what is the lowest? 45. And what is the dispersion range? So 21. Let us do that of B. What's the highest? 87. What's the lowest? 24. What is the dispersion range? 60 what? 63. Now, if you are going to given this data and then you are being told that the mean is what? The mean is 56. You cannot be able to know how the max is being spread. Above or below what? Below the mean. So you are going to ask what you call dispersion what? Range. If you are going to given the mean of A, that's 56, and dispersion range of A, that is 21, then you can able to know that the max are very closer to the mean. Again, if you are going to given the mean of P, which is here, and then you given the dispersion range of P, which is 63, then in your mind, you can have that picture how the max is being spread. Are you getting what I'm saying? Now, but the problem of this is going to focus only to what? Two max, the highest and the what? And the lowest. Now we're going to use another dispersion measure. We're going to use what we call interquartile range. We're going to calculate what we call interquartile range. Now let us focus with data what? Data P, all marks of student P. So let us arrange this data from the smallest to the highest. Arrange for me. 24, 32, 38, 49, 55, 78, 85, 87. Now, from here, we can able to find the median, isn't it? If we're going to have the median, what will be the median? The median is going to be 1, 2, 3, 4. So 1, 2, 3, 4. So if we're going to average this, we're going to have the median. And the median is going to divide this data into two halves. Are you getting? So which means the half of this data is going to be here. Have you seen the way I've done? Now, the median of the first half in the next one lower quartile. Lower quartile tunaiandika aje? How can I write the lower quartile? Q what? Q1. In this case, we want to find the median of this. The median of the lower half. And the median of the lower half in the next one lower quartile. So we're going to average this. This is 32 plus 38. Then we divide by 2. So what's the answer? 35. Now, we want to find also Q what? Q3. Q3 is the median of the second what? Of the second half. So what is the median here? So we're going to average these two. So what do you get? 81 point what? 0.5. Now, if you are going to find what called interquartile range, the upper quartile Q3 minus what? Minus Q1. So that is 81.5 minus 35. What's the answer? 46 point what? 0.5. This is how we're going to find what called interquartile range. Are you getting? But we can continue further and find what called semi-interquartile range, or what they call quartile deviation. So how can we find quartile deviation? So we have to find semi-interquartile range is equals to interquartile range divided by what? Divided by 2. So what is interquartile range? 46.5 divided by what? Divided by 2. So what's the answer? 23.25. So we have seen how to find interquartile range. We have seen how to find semi-interquartile range, or what we call quartile deviation. We learn to use, let us use data P. What's the deviation of here?
Negative 29.
Negative 29?
24.
Negative 24?
Positive 24.
24?
1.
Now, if you are going to add deviation, it's going to give us what? We're going to get 0. Are you getting what I'm saying? If you are going to add all this deviation, it's going to give us what? It's going to give us 0. Then it does not assist us, because we want to know how the marks is being spread. Are you getting? But if we are going to add this, it's going to give us what? It's going to give us 0. So what we're going to do, we're going to use what's called absolute deviation. In absolute deviation, we're going to assume the negative. Are you getting what I'm saying? So what is the absolute deviation of this? It is just 29. What's the absolute deviation? These are positive. If it's a positive, it's going to remain a positive. So it's going to be what? 24. Itaka 1. Itaka 31. Itaka 32. Itaka 22. Itaka 7. Na itaka 18. Have you seen? So hii ndio inaitwa nini? Absolute deviation. And I have said that absolute deviation, we're going to ignore what? We're going to ignore a negative. But if it's 0, then it's going to remain 0. Are you getting what I'm saying? Now, we're going to have what we want to find the mean absolute deviation. So let us find the mean absolute deviation. I'm going to call mean absolute deviation. Mean absolute deviation. What is the thought of this absolute deviation? If you do everything. So what do you get?
164.
164. 164 divided by what?
8.
Divided by 8. So what's the answer?
20.5.
20. So this is called what? Mean absolute deviation. We have got what we call mean absolute deviation by ignoring what? By ignoring a negative. It is okay. But mathematics, you can ask, why do you ignore a negative? Now tell me, why do you ignore a negative? It is logic that we are going to ignore a negative. So if we don't have a good reason why we ignore what? We ignore a negative. Are you getting what I'm saying? We don't have a good reason why we ignore a negative. To avoid that, we can have what we call d squared. We can find what we call what? D squared. And that comes what we call variance. So we're going to discuss what we call variance. Instead of ignoring a negative, then we can square. So we're going to discuss what we call variance. Variance like this. Now, I want you to look up I have said that instead of ignoring a negative, can you look up? Instead of ignoring this negative, we can do what? We can square. So if we square this, what do you get? So d squared. So 8, 41, 570, 576, variance is equals to summation of d squared divided by what? Divided by frequency, or divided by what? Divided by n, like this. So if you add, what do you get? Summation of d squared. So we're going to add the whole of this. Now we're going to have 4260 divided by what? Divided by 8. What do you get? 5 32.5. Hii ndio inaitwa nini? Variance. Standard deviation. So we talk about standard deviation. Sawa? So standard deviation is the square root of what? The square root of variance. So we talk about the square root of then 532.5. So what's the answer? 23.08. And this is what we call what? Standard deviation. Have you seen the way we have done it?